Okay, in this next question, we're doing a proof, and it's popular to do proofs about things being odd and even, things like that. So let's take a look at this one. This is proved by contradiction. So we have to make an assumption and show that leads to a contradiction. And our assumption is going to be, we're going to be proving that A and B cannot both be odd. So our assumption is that they are both odd. Assume A and B are odd. Now it's a proof, so the mark scheme is generally very picky for these questions. You have to write the word assume, not let or something like that. So you have to write the word assume, and then this means that you can write, now odd numbers, you can write them like this. You can write them as like A equals 2n plus 1, and B equals 2m plus 1, where n, m are integers. Okay, this is how you write odd numbers for proofs. So now let's just do a squared plus b squared. So a squared plus b squared equals, and actually the mark scheme uses the equivalent sign, is equivalent to 2n plus 1 squared plus 2m plus 1 squared, which equals 4n squared plus 4n plus 1 plus 2m. Oops, that should be 4. 4m squared plus 4m plus 1, which equals 4n squared plus 4m squared plus 4n plus 4m. I'm kind of grouping them together. So often these proofs involve some sort of factorizing, and I've grouped them together like this. And we want to get the contradiction with the divisible by 4 thing. So this is not divisible by 4, and the way you can show that is you can factor out a 4. If it is divisible by 4, then you should be able to factor out a 4 from everything. But you can factor out a 4 from these first 4 terms, but not the last one. Okay? This means actually it's 2 more than a multiple of 4. Okay? Or you could say maybe just therefore a squared plus b squared is not a multiple of 4. 4, which is a contradiction, because they're supposed to be a multiple of 4, right? It's supposed to be a multiple of 4, contradiction. Okay, therefore, or thus, or something, our assumption must be false. Therefore, A and B are not both odd. And that's it. That's how you do a proof by contradiction.